Hello students, today we will be solving the IB Math AHL May 2025 paper 2 time zone 1 question number 8. You will be getting the solutions for the first 7 questions of this paper and the solutions for the other questions from the other past papers in form of playlist on my channel in its online math tutoring classes. You will also be getting playlists where the solved past paper questions will be available based on their topics. I am Nilanjana Sanyal. I am an online IB Math AHL level tutor. My phone number and my website address are displayed at the bottom of the screen. And as you can understand, I'm having a severe throat problem, but I have to record these videos now. So please bear with me. I'm also having my classes with my students. So even they are facing some difficulty. Okay. So without any further delay, let us start to solve this question number 8. The maximum mark is 7. Consider the functions f, g and h defined as follows for t belonging to the set of real numbers. F of t is equal to sine 2t plus 1, g of t equal to sine 2t plus 3 and h of t equal to f of t plus g of t. So part A's question is show that h of t equal to the imaginary part of e to the power of 2ti times e to the power of I plus e to the power of 3I. Okay, so first of all, let us expand this. Okay, so e to the power of 2ti multiplied by e to the power of I plus e to the power of 3I. So this will be equal to, I'm multiplying this with this. So it is, the powers will get added, the exponents. So this is 2ti plus I and plus, now this is getting multiplied with this. E to the power of 2ti plus 3I. Okay. So this is equal to e to the power of 2t plus 1I plus e to the power of 2t plus 3I. Okay. Now I'm seeing that f of t and g of t, these are having the sine function. And this is in Euler's form. So let us change these two to polar form so that we can get cos and sine. Okay. So this will be equal to cos 2t plus 1 plus I sine 2t plus 1 plus cos 2t plus 3 plus I sine 2t plus 3. Okay. So now we can come to this portion. Okay. So imaginary part of, therefore imaginary part of e to the power of 2t plus 1I plus e to the power of 2t plus 3I should be equal to sine 2t plus 1 plus sine 2t plus 3. Okay. And sine 2t plus 1 is f of t and sine 2t plus 1 is 2t plus 3 is g of t. So this is equal to f of t plus g of t. And this one is h of t. Let me write this over here. H of t is equal to this. So this is equal to f of t plus g of t. Okay. Shown. So part B, write e to the power of I plus e to the power of 3I in the form of r times e to the power of I theta, where r is greater than 0 because r is the modulus, and theta is greater than negative pi but less than or equal to positive pi. Okay, so subpart B, e to the power of I plus e to the power of 3i. Okay, you can use the calculator. Rather, okay, let us write these few steps because it is containing 2 marks. So e to the power of I is e to the power of 1i. Therefore, this will be equal to cos 1 plus I sin 1 plus cos 3 plus I sin 3. Okay. And if we group the real and the imaginary parts, we get cos 1 plus cos 3 plus I sin 1 plus sin 3. Okay. And this is of course in Cartesian form. We have to come to this. So now we can use the calculator. Calculator, cos 1 plus cos 3. Okay, let us first of all get these two. The value of cos 1 plus cos 3. I can use the complex arithmetic also, but I'm not going into that. You may, if you want, you can use the complex arithmetic, but I'm not going into that detail. Okay. Cos 1 plus cos 3, and make sure that your this degrees, angle settings is in radians. Okay, because 1, 3, these are in radians. So this is negative 0.44969 I am taking. Okay, don't take two answers till correct to 3 significant figures because this is not the final answer that we are giving. So I am writing negative 0.44969. So negative 0.44969 plus, let us find sine 1 plus sine 3. Okay, so sine 1 plus sine 3 is 0.98259 I am taking. Okay, 0.98259. So 0.98259 I. Okay, and we have to change it. So R will be negative 0.44969 whole square plus 0.98259 whole square. Okay. So now let us use the calculator. It is square root, and this part is the answer. So I'm writing this part first. Doesn't matter because they are connected by a plus sign. So answer square plus, there is the minus sign over here for the first part. So I can put a bracket and then I go up and it is control C, and I come down, control V, come out of the bracket and square. Okay, and enter. This is the value of R, 1.0806046. Okay, let me take up to 1.0806. Okay, so this is 1.0806. This is the value of R. Okay, and what is theta? theta will be equal to tan inverse of this divided by this. Okay, so 0.98259 over negative 0.44969. Now this time I'll be taking the numbers that I am writing over here, because students may think that for calculating the R, you did not take these. You have taken the full answer, and so you have got the value of R as 1.0806. But what if we take these? Will we be getting the same answer? Yes, of course, you will be getting the same answer. You may try. Okay. So, therefore, for getting the value of theta, let me use these numbers. Okay. So, it is tan inverse of 0.98259 over negative 0.44969. Enter. We are getting a negative value for theta. Yes, of course, we can get a negative value for theta because theta is between negative pi and positive pi. So, theta can be a negative angle. But the problem is that the number is this. The real part is negative and the imaginary part is positive. Okay, if you think about the Argand diagram that you draw, this is the real part, this is the real axis, and this is the imaginary axis. Okay, so real numbers are negative in this side and imaginary numbers are positive on this side. So this number will be placed somewhere over here in the second quadrant. Okay, this you have to understand. And it is said that theta is between negative pi to positive pi. Positive pi means 0 to positive pi means the positive angles are from the first quadrant and the second quadrant. And the number is from the second quadrant, so we have to get a positive value of theta. Just do not write whatever value you are getting from the calculator. That will be wrong. Because you have to see in which quadrant is the number lying. Okay. It is lying over here where the real numbers are negative and the imaginary numbers are positive. So theta should be a positive angle. Therefore, what can we do to find the positive angle, the angle from the second quadrant? Let us take some alpha. Alpha will be an angle from the first quadrant. It will be an acute angle because I will be just ignoring this sign. Whenever, even in trigonometry, this is a question from complex numbers. Even if you have a question from trigonometry and you are trying to find the angle somewhere, then you just remove the negative sign and get the acute angle value first of all, and then you can get the corresponding angle from any of the second, third, or the fourth quadrants. Okay, so 0.98259 over 0.44969. Okay, let us see what value do we get for alpha. So this is again tan inverse. It is 0.98259 over 0.44969. Now let's see what do we get. See, this is the positive angle. This was from the second quadrant, fourth quadrant. This is the angle that we had got, the negative angle. It was from the fourth quadrant. And this is the positive angle, which is the acute angle. And this is from the first quadrant, 1.14159. Okay. So 1.14159. And since theta is from the second quadrant, theta will be equal to pi minus alpha. Let's find theta. It is pi minus, and the answer, it is 2 point, we can take the answer as 2, the theta value as 2, okay? So theta is 2. So therefore we can write the question was, right, e to the power of I plus e to the power of 3i in this form, r e to the power of I theta, okay? So therefore e to the power of I plus e to the power of 3i is equal to r's value, correct to three significant figures, will be 1.08, and e to the power of I theta means it is 2i, okay? Correct to three significant figures. So we have come to the correct answer, but you may think that it is, this question is containing 2 marks and I have written so many steps. So even you have to write so many steps. Most probably you will not be checking this minus sign. You will not be realizing that you have to take the plus sign first and then it is the second quadrant angle. So you will not be realizing these in the first time. So you will be taking more time. It will not be completed within 2 minutes. So what can you do? I was saying that I am not showing the complex arithmetic. Now I am showing the complex arithmetic. How to find it in the shortest possible way, in the shortest time possible. Okay. So I have written this. You can also get it directly from here. If you take e to the power of I plus e to the power of 3i, this, the calculator will be giving you this step. Okay, let us see how does it give you. Eh, how does it give you means you will be just entering and you will be getting the answer. It is that simple. E to the power of I, so e to the power of, but you don't type from this keypad. You don't type the I from this keypad. You have to press this button with the pi. Okay, you see I is in bold. Okay, you have to take this I, not the I from the keypad. Okay, plus e to the power of, okay, I times 3 I can write, since I have already inputted I, so I can write I times 3. Okay, and enter. So you see negative 0.44969, that is what we have got over here, plus 0.98259, 0.98259 I. Okay, so you have got the Cartesian form answer of this e to the power of I plus e to the power of 3i. This is in Euler's form, and we have got the equivalent Cartesian form answer. And in order to come to this final step from this Cartesian form to this form directly, let me show you what you have to do. We go to the menu and then it will be the number. Number 2 is, it is number 2. And you see it is the option number 9, complex number 2. Okay. It is option number 9, complex numbers 2. And then option 6, convert to polar. Okay. Option 6, convert to polar. Enter. See, 1.0806, this is the R's value, 1.0806. Correct to three significant figures, it is 1.08, and it is e to the power of 2i. E to the power of 2i. Directly you are getting this answer. You do not have to get the positive acute angle, then convert it to an angle from the second quadrant between pi over 2 and pi. You do not have to do any of these steps. You can, from here directly, you will be coming to this answer. So you can use this method also. It will be saving some time. Okay. Now coming to part C. Hence or otherwise, write h of t in the form of p sine 2t plus q. where p is greater than 0 and q is greater than 0 but is less than 2 pi. Okay, and h of t was the imaginary part of 2ti times e to the power of I plus e to the power of 3i. Okay, so part C, h of t is equal to imaginary part of e to the power of 2ti times e to the power of I plus e to the power of 3i. Okay, and e to the power of I plus e to the power of 3i, we have got this in polar form as 1.08 e to the power of 2i. Okay, so we can write this portion, this polar form, instead of e to the power of I plus e to the power of 3i. So this is equal to imaginary part of e to the power of 2ti and times by 1.08 e to the power of 2i. Okay, this is equal to imaginary part of, this is the modulus, so I can take this in front, and it is e to the power of, I'm multiplying this with this, so the exponents will get added, 2ti plus 2i. So this is equal to imaginary part of 1.08 times e to the power of 2t plus 2i. Okay, so, and what is e to the power of 2t plus 2i? This is equal to cos 2t plus 2 plus I sin 2t plus 2. Okay, so the imaginary part of this is sin 2t plus 2. 1.08, it is a real number, so it will definitely not have any imaginary part. This will be having the imaginary part. And what is the imaginary part of this? It is sin 2t plus 2. Okay, so this is equal to 1.08 times sin 2t plus 2. This is h of t. You see, 1.08 is p is greater than 0, and sin 2t plus q is 2. It is between, obviously 2 is greater than 0, you know that. And obviously 2 is less than 2 pi, because pi is what? 3.14159. Even if I take it as 3, 2 times 3 is 6. So 2 is less than 6. Okay. So 2 is greater than 0 but is less than 2 pi. So the q value is 2 and the p value is 1.08. So this is our answer. So we have completed solving this question. Thank you for staying with me till the end. Please like and share this video in case you have liked my explanation. And please do not forget to subscribe to my YouTube channel. Your liking, sharing and subscribing will be really helping me a lot. It will be motivating me. It will be increasing my videos reach. So please do like, share and subscribe. We meet again very soon in our next session. We'll be solving the question number 9 of the same paper. Till then, bye.